Hi guys, welcome back to AI with MJ. Today I'm going to be starting this new playlist which is Leetcode's Interview Crash Course, and it's for data science and algorithms. I have an interview coming up and the goal is to finish this course in like 5 to 7 days. And it just has like famous topics like most commonly asked interview problems. So arrays, strings, hashing, trees, graphs, and so on. And then yeah, it has like bunch of examples and stuff as well. So for this video, it'll be like the introduction, which is basically introduction to Big O and also introduction to recursion. This testimonials and stuff is not that important right now. And yeah, the most videos will not be more than like 25 minutes, and max it'll cover is like one or two lead code or like questions which would be based on that specific pattern. So it's for I've solved this one before, but it's for anyone who's like watching out there and like maybe need a quick refresher of what's going on. All right, let's get started. So introduction to Big O. You can obviously skip this if you know what it is. And before we talk about it, we need to first understand what an algorithm is. We know what an algorithm is. It's basically like a recipe for a computer to follow. It takes an input and it produces an output, and there could be like different kind of inputs and outputs, right? Like integers or text space and floats and so on. Okay, so it should be deterministic. So given the same input, the algorithm should always produce the same output. So basically, there shouldn't be any randomness. Yeah, and what is big O? Big O is the notation that is used to describe the computational complexity of an algorithm. And it can be split into two parts, time and space complexity. Time complexity is when, like, how much time an algorithm needs to run relative to the input size, while the space complexity is like how much memory will the algorithm use relative to the input size. Usually we just care more about the time complexity because space has gotten like way cheaper right now. Yeah. And how does it work? It's basically a mathematical formula that we use to calculate complexities, and how, like, what should the variables in this function be. The variables are defined by us, but then, like, how do they affect the eventual time it takes to run, or like space it takes, depends on this complexity. And these are like the most common complexities out there. So if we look at this graph, it tells us like how long will it take for it to reach a certain time complexity. So for example, if we are giving in the input, and if it's like constant, then it would be O of 1, but if it's O of log n, it will be like not so growing exponentially. It will be very subtle because log is obviously an addition, while if it's O of n, this is like a linear, that if increases, y increases by 1, for example. And log n, that is like n, and then log n, so not the best. And here the color code describes like excellent, good, fair, and so on. These are like the worst time complexities to have. So n squared 2 to the power of n, or n factorial. That is usually in like graph problems or maybe DP, but we try to optimize it and bring it down to like for one of these four. That's the goal. Same for like space complexity as well. Okay, yeah. And then how we calculate it, there are few rules. So for example, this is one that we ignore all the constants. So if even if it is 8n, we are just gonna like take it as O of n. And why do we do this? Because if you have two algorithms and A uses approximately n operation and B uses 5n operation, so when n is 100, A uses 100 operations, and when B will use like 500 operations. And then what happens if we double the n? So it uses 200 operations, and then the other one will use 1000 operations. So we see that when we double the value of n, both algorithms require double the amount of operations. So if we were to 10x them, then the value of n would be would just require like 10x more operations. So that's why we just treat them as like, we ignore the constants, because it just makes it more complicated. And the second rule is that the complexity as the variable tends to infinity. So when it's like addition or subtraction between the terms of same variable, we ignore all the terms except the most powerful one. So in this one, this whole equation, we'll just take 2n, because in the grand scheme of things, this number would not make much difference and our calculations would be a lot more easier. And then we usually just talk about the best case, average case, and the worst case scenario. And then when we are discussing it during interviews, we usually just do the worst case and optimize it for that. But still good to mention. And then these are just few examples, but I'm not gonna go into them right now. And then when we go to this introduction to recursion, if you can understand it, you can just go ahead. And recursion is a problem solving method, and it is used using a function that calls itself. If you're not familiar with recursion, this is not the best video to watch. So I would recommend like going and checking out some other resource. This is just a quick refresher in case you have forgotten. So what happens in recursion is, you're doing function of f of n I, and then you're printing that number, let's say, and then you're calling the next number, and then you return. For the recursion to end, you need to have a base case. So for example, in this question, this becomes like, if I is bigger than 10, then we just end the function right there. And what happens is that after every function call, a function call is added to the stack or like some kind of data structure until the call is over, and that could be removed from the data structure. So here is an example of this. So you'll print like 1 2 3, but then 3 would be stored in the function stack, and then we'll do call 3 2 and 1 again to get done with the recursion part. Like it just moves back up. And here is that example. So if we are doing an I is greater than 1, so it should just print like 1 2 3 and then 3 2 1, where end of call would be this. So 1 is printed, 2 is printed, and then 3 is printed. So till here the lines got executed, and now it will do this, we return. So we come out, and now this print end of call would be executed, but 3 would be on the top of the stack. So we print like end of call where I is equal to 3 2 and 1, and that's how the function completes. And this is another like Fibonacci number problem, where this number, like the last number here, would be an addition of the previous two numbers. So here we just do like 1 back and 2 back, and then we just add it, and we call this function inside this function with a base case. So yeah, that is it for recursion as well. In the next video, I'm gonna be going over arrays and string, and this has like 2 pointers, so a few example there, and then we'll go from there to complete that module. Yeah, I don't think it's like for someone who's a beginner, but if you're just trying to remember and like apply it or revise it, this would be a good resource for you. But yeah, thanks for watching. Hope you come back.